Okay, so these are the solutions for the second integration by substitution assignments. So we have the integral of x squared plus 5 quantity squared x dx. And I put the x at the end just to make it more obvious what's going on here. So the first thing you try is you try u to be, u to be equal to what is inside the parentheses. So if we take du, we get derivative of x squared, which is 2x, and then we multiply it by dx. So you see that we have x dx in our original expression. So we want to take the last thing we have here and divide by 2. So you get du over 2 is equal to x dx. So we can make that substitution here, and we can make this substitution there. So in terms of u, we can rewrite this as u squared times du divided by 2. So that's what we're going to integrate. So you take out the 1/2 outside of the integral signs, and then you just have a polynomial in terms of u. So we use the integral of x to the n, or u to the n. So that'd be u to the n plus 1 over n plus 1. Because it's a indefinite integral, we add our arbitrary constant c. And then we substitute u back in. So what we'll get, u cubed will be x squared plus 5 cubed, and we can simplify the denominator by multiplying those two together. So that's our answer for problem number 1. Okay. Next thing, we have x cubed over the square root of 1 plus x to the 4th dx. Again, what's in parentheses, or the argument of a square root, is typically what we would take as our first shot. So when we take the derivative here, we'll get du, and the derivative here is 4x cubed, and then we add the dx on the end. We go back to our original expression now. Once we've chosen u and calculated du, we go back and look to see if it worked out or not. So we have x cubed dx. Here's x cubed dx, so we divide both sides by 4. So again, we can substitute here for this part, and we can substitute here with that. So in terms of u, we get 1 over the square root of u, and this part becomes du divided by 4. So that's the integral we need. Now we're going to need to rewrite this fractional exponent. This square root is a fractional exponent, and we're going to need to move it to the numerator. So this part, 1 over the square root of u, becomes u to the minus 1/2 power. I'm going to go ahead and factor out the 1/4. Again, now we have it in terms of u as a polynomial, so we can add 1 to the exponent, divide by the new exponent, add our arbitrary constant c because it's an indefinite integral. 4 times 1/2 is 2, so we're going to have u to the 1/2, which is the square root of u, divided by 2 plus c. So what we've done is change this to the square root. 4 divided by 2 is 2. And then we plug u back in, so we get the square root of 1 plus x to the 4th over 2 plus c. Okay, next one. 5x dx divided by 4x squared plus 2 to the 4th. So again, what's in the parentheses, we would typically choose first as an option. So we're going to get 4x squared plus 2 du. The derivative of x squared is 2x. 2 times 4 is 8, so we get 8x. The derivative of 2 is 0, so we don't bring that down, so we get 8 dx. Now, what I'm going to do is I'm going to find a substitution for this thing. Just x dx. The 5 we can bring outside the integral. So we need to divide both sides by 8. So we get du over 8 is equal to x dx. So bring the 5 out. This is going to be, the x dx is going to be du divided by 8. And this one is to get 1 over u to the 4th power. So let's go ahead and pull that 8, which is in the denominator, outside. We'll rewrite this as u to the minus 4 power. So we use our x to the n integration. So we'll add 1 to the exponent, divide by the new exponent, add our arbitrary constant c. So in terms of the numbers at the beginning, we have negative 5 over 24. 8 times 3 is 24. We're going to move u to the denominator to make it positive exponent. And then we're going to substitute back in for u. Use parentheses here. Make sure we know we're cubing the whole thing. Forget our arbitrary constant c. We could say it's 5 divided by 24 times that if you wanted to. Okay, now the next 3 are definite integrals, which means there's 2 things. One is we're going to get a number, and secondly is we're going to change our limits reflect our u substitution instead of substituting everything back in. So that's one extra step we have, but it helps because then we don't have to go back and substitute u back in. We just evaluate the integral in terms of u instead of in terms of x. So let's u equal what's inside the square root. Du is equal to 2x dx. Derivative of x squared is 2x, add the dx. So we already have 2x dx. Okay, now normally we would substitute in, which we're going to do, but we're also going to change our limits. So when x equals 1, which is our lower limit, u is going to be equal to x squared minus 1, or 0, in this case 1 squared minus 1. And when x equals 2, u is equal to 2 squared minus 1, which is 4 minus 1, which is 3. So when we make our substitutions here in the definite integral, our derivative integral is from 0 to 3 instead of from 1 to 2. We have the square root of u instead of the square root of x squared minus 1, and we have du instead of 2x dx. Okay, so we will rewrite the square root as a fractional exponent. Then we will integrate, add 1 to the exponent, divide by the new exponent. We don't add the arbitrary constant c. We put these straight lines to show the upper and lower and upper limits. I'm going to take the reciprocal of that, so I'll have 2/3. And what we'll do is we'll have u to the 3/2. So we put 3 in there, 3 to the 3/2, minus the lower limit, which is 0, 0 to the 3/2. In this case, let's just use our calculator to come up with a decimal number. So 3 to the 3/2 power is 5.196 times 2 divided by 5. And so the answer is 2.08. Now we could have kept the original limits. We could have plugged it back in if we change it from u back to x, but then we would have had to change the limits back. So there's really no point in doing that. Because all we're looking for with the definite integral is an answer. Okay, the next one, integral from 2 to 3 of x divided by the square root of x squared plus 1 dx. So we're going to let the argument of the square root be u. du is the derivative, which is 2x dx. You can see we have x dx, so du over 2 is equal to x dx. Now we need to redefine the limits, so when x equals 2, u equals 2 squared plus 1, which is 5. And when x equals 3, I'm going down here, doing the u thing here. U is equal to 3 squared plus 1, which is 10. So now I can rewrite my original integral as the integral from 5 to 10 instead of from 2 to 3. X dx is going to be equal to du divided by 2, and then we'll have 1 over the square root of u. So we're going to rewrite the square root as a fractional exponent and move it to the numerator. I'm going to go ahead and factor out the 2. So we end up with 1/2 the integral of this, which you're going to add 1 to the exponent, divide by the new exponent, draw your vertical lines to show your limits of integration, which are in terms of u. Notice these cancel out, 2 times 1/2 in the denominator. So now u to the 1/2 is the square root, so we'll just have the square root of 10, which is evaluating that at the upper limit, minus the square root of 5. So let's plug that in our calculator. Square root of 10 minus the square root of 5, and I get 0.93. Okay, the last one involves trig functions. So we're going to have the integral from pi over 6 to pi over 3 of the tangent squared of x secant squared of x dx. So this, you may not see this originally, but what we can do is group tangent and secant together. So you'd have tangent of x secant of x quantity squared dx. And so what we're going to do is let u equal, yeah, that's not going to work. Okay, sometimes that happens. Okay, so let's not do that. The derivative of the tangent is the secant squared, so that sounds like a better substitution. So let me erase that. Let u equal the tangent of x, and du will be equal to the secant squared of x, which is the derivative of the tangent dx. So this part will be du, this part will be u squared. Same thing, we've got to change the limits from x to u. When x equals pi over 6, u equals the tangent of pi over 6, which, if you remember, is the square root of 3 over 3. And when x equals pi over 3, u equals the tangent of pi over 3, which is equal to the square root of 3. So those are the, how did I know that besides I just remembered it? How would you figure it out? Well, you know, the tangent of x is equal to the sine of x divided by the cosine of x. So pi over 6, sine of pi over 6 is 1/2. And the cosine of pi over 6 is square root of 3 over 2. So when you take the ratio, sine over cosine, so the tangent of x is going to be 1/2 divided by the square root of 3 over 2. These cancel out. You get 1 over the square root of 3. Multiply numerator and the denominator by the square root of 3, and you get the square root of 3 over 3. And for pi over 3, it's the other way around, so the sine of pi over 3 is the square root of 3 over 2, and the cosine of pi over 3 is 1/2. So the tangent at this value is the square root of 3 over 2 divided by 1/2. 2's cancel out, you get the square root of 3. Okay. So anyway, that so what we're going to do is, instead of integrating from pi over 6 to pi over 3, we're going to integrate from the square root of 3 over 3 to the square root of 3. Now our substitutions, we're going to have u squared for this, tangent of x squared. Remember, this is tangent of x, quantity squared, so it'll be u squared du. So we integrate, we get u cubed over 3. Because it's a definite integral, we're going to use the limits instead of adding an arbitrary constant c. And now we can evaluate it. So I'm going to take the 1/3 out, and then we'll take the square root of 3 cubed minus the square root of 3 over 3 cubed. And let's plug that in our calculator. So 1 divided by 3, so that's 1/3 times square root of 3 cubed minus the square root of 3 divided by 3 cubed, close parenthesis. Got to make sure you close enough parentheses here. Oh, I must not have had enough. Let's try it again. So okay, I need one extra parenthesis in there to start with. Oh, I still got it wrong. Okay, I'm just going to have to think a little harder here. Square root of 3 cubed. Wonder why I didn't put that in there. Okay. Just making sure I got all these things. Oh, I know. Didn't do a power here. Okay, square root of 3 over 3 cubed. Okay, so I get 1.67. Okay, I'm going to pause it for a second and just double check all these answers. The definite integral checks. Okay, so first, yeah, did make a mistake there. I don't know, I just did a calculator error. 3.46. So 3 to the 3/2 times 2/3 gives you 3.46. So that one's correct now. So let's pause again and do the next one. Okay, the other two are correct. So it's just that first one that had that calculator error.